In this video, you will be presented with an overview of a .NET Azure App Service Diagnose and Solve Problems Generated .NET Profiler Trace report, which was captured to diagnose an application exception. Additionally, the manual analysis of the same trace using PerView on your local machine will be discussed. It is expected that you have already downloaded the .NET Profiler Trace and PerView. A link to the video showing how to capture this .NET Profiler trace is provided in the description below, as is a link to the official PerView download GitHub repository. Select the web link icon next to the instance name to open the .NET Profiler Trace Analysis Report. Navigate through the different tabs and analyze the findings. For example, .NET Core, slow requests, failed requests, .NET Core failed request, thread call stacks, .NET exceptions, and CPU stacks. We're troubleshooting a application exception, so click on .NET Core failed requests. This tab contains failed requests. Note the path name of the failed request. Click the .NET Exceptions tab. Notice the exceptions shown on this tab, which renders an exception stack that contains a non-Microsoft assembly named C# guitar. This is a clear clue and is a point of great interest. Provide this input to the party owning the assembly and have them investigate the code. To analyze the .NET Profiler trace locally, open the .diaccession file in PerView. Double-click the .diaccession file. It will take a few moments to load, so be patient. Once loaded, double-click or expand the .diaccession file to expose the ETL file. Double-click the ETL file. Expand the Advanced folder and double-click Exceptions Stacks. As this is an IIS-hosted website, take notice of the W3 WP process. Double-click the W3 WP process. The Exception Stacks window opens. Select the By Name tab, and you will notice the same exception which was rendered on the analysis report. Select the Call Tree table and navigate into the modules, check by check until you reach the non-Microsoft assembly. From here, you can see the page name and the methods in which it is calling. Alternatively, you can place the name of the page identified in the analysis report and search for it. Unhandled, which results in the same conclusion. Provide this input to the party owning this assembly and have them investigate the code. And finally, but extremely important, is to recognize that memory dumps and .NET Profiler traces contain very sensitive information. Take extreme precautions and follow the documented procedures for handling of these files. Remove them from all devices once they are no longer needed.